What's wrong with Science 1? It's like the pinnacle.
But it's a nice build. Yeah, it's nice, but it's like no, Austin building. Oh yeah, Austin building's fine. Kill the Ken building, yeah.
All right.
This is not moving on the live.
All right, we're back. Yeah, and with that bug in Husky CT, like some people like couldn't find module 0 to submit assignments. So anything like weird like that, I'm never gonna. Well, in general, I'm not gonna penalize late submissions. And like if you're submitting something, it was due at midnight and you submitted at 3 a.m. Like you don't need to ask for permission. Like that's no one's gonna see it before, other than the fact that it has like this was turned in late, but there's no late penalties to begin with. If it's gonna be, if you know like I'm not gonna get to the assignment for the next 3 or 4 days, then submit a note. Yesterday well, this one would have been hard because there was nowhere to submit anything, but give us a note that says when are you going to turn it in, and then what help do you need. So if it's like conceptual stuff, then say that you're going to meet or come to class and ask a question, or if it's just time, like I've got 6 other projects due right now, I just need 3 more days, that's totally fine. A week is fine. If it's going to be like 5 weeks, like hey, I'm leaving the country for the next month, I'm not going to do these assignments, then we need to talk, because now we need like a real strategy of how we're going to condense all the assignments and get them all submitted in time so that you can get some feedback, get credit for learning. Sound good? Cool. And now, right now, I didn't expect anyone to like have all the module 1 readings done, but this is kind of like now we can start getting into the meat of the class. So we've done some review stuff, like quiz 0 hopefully felt like review. That homework 0, where it was like intro to Python, probably mostly new, because at least this has been my experience, is that CSE 1010, you take that, and then for the next 2 or 3 years, you desperately try to forget it. Like, not to say like it's just that has been. It seems like that is the general process. So that first Python assignment probably felt like mostly new stuff, like maybe sort of brushing up some cobwebs. Now we can jump into like some engineering physics kind of work. Sound good? Cool. Start off with chapter 1, problem 1. And here, just a reminder, all the textbook chapters, we can get to them through the library. Oh yeah, there's always like, but this Kasdan Paley book, it's one of the reasons that I chose this book. I like the way it's set up, and then also we have access to it. So yeah, here's chapter 1, just kind of skipping over everything. We'll grab it. Oh, there we go. This way. No. There we go. All right, so we have this box, and then a reference frame, and we're trying to figure out where point P is on that box. What kind of problem is this? Like, why are we looking at points on a box in a dynamics class? Like, this doesn't seem very dynamic, right? It's just like locating a fixed position. What kind of problem is this?
I think it's just like a knowledge skill check, whatever, to make sure we know how to use, like, identify a point Cartesian coordinates. Because say you want to like track something moving.
Okay.
I don't know if you're gonna track. You might track a certain point, but you're probably gonna be interested in like center of gravity. And you have to
Center
know
of
where it
gravity,
is.
yeah. And then probably also like moving parts of it, yeah. Yeah, so like motion and tracking and these kind of things are all like general kinematic sort of problems. So here, this is a kinematic problem. Right now we're looking at like a fixed point in space, fixed point in time, but you could, like, this could be a moving box, right? Like, what if we were trying to track point P as the box is rotating and moving away? But either way, we still need that same kind of process. So take a minute. I want to see how you do this, because I think a lot of people have an idea of what they would do, but I want to know what we're working with to start. Well, this one is just like doing problems. So it's true. Like open the textbook and then
You like module 0.
that's only comes up in there in the notebook. Like right now it's just like
Oh, okay.
yeah, like that.
Yeah, why?
Sure. So we're just
You know, I know
like,
there's something
about
about
like
like
metaphors.
This is like homework.
Oh, this is the one.
Yeah.
Okay, but it's not module 1. That's not Python module. It's not.
No.
Oh, that's fine.
Yeah, this one. I mean, you can do all this stuff in Python.
Oh wait, why is it? Yes, it's a bone. What? No.
Oh yeah.
No, the bottom
It's
face.
like-
The bottom face.
The bottom face is all the
way.
way. So for a second, I thought that like,
I made a mistake. It should be difficult.
Any better? No, that's too dark.
Well, actually, I have to calculate with my calculator. That's just what I was saying.
No, wait.
6.9.
Yeah, nice.
It's at 6.98, -3.64, 0.9.
Okay.
What? Why is it going in the negative direction? Did I add?
Assume it's going in the positive y direction. It's labeled as y.
What are you talking about? When has that ever been positive y direction?
Never, like, I'm going to assume it is because I don't want to change that.
It's literally one negative, no, it's -3.64, but it's not like physical combination. I guess you can draw, actually, that's a good point. Ironically, you should draw indicating which direction is positive.
Oh, oops.
No, it's EY points to the
So this was kind of general process that I've seen so far is that X, Y, Z of like figure out what is X, what is Y, what is Z, and then there we go. That's our. Is this how like vectors? Were you taught like vectors are parentheses like that? Yeah. Have you seen unit vectors before to describe what would that one look like? Oh, if you want like unit vector pointing at P, right?
Like
IJK, yeah, what would that one look like?
you just take the next I plus y plus yj plus zk.
Yeah. I gotta zoom out a little. Kind of like that. Have you seen this one before? IJK. They're both technically they're both the same. The hard part if you're always using like parentheses like that, and you have two coordinate systems or three or four. So general kind of multi-body dynamic problems. Every time you add a piece to the ground has a coordinate system. One moving part has another coordinate system, another has another coordinate system. Like if you're using any kind of dynamic software, everything has a local coordinate system and there's a global one. So if you're using kind of that so if you're doing something like this, I would do something to say, like this is XYZ in that I frame. Like this is, I'm measuring things in this little I, like that coordinate system. That's the one thing that is a little hard about using that, like this kind of notation. But technically, it is still the same. But like we were just talking, like what if you wanted the unit vector, like in that? Because really, what we just did was describe this vector RP/O. And that unit vector, EPO, is XI plus Y. Oops. Or same thing, like we could have that parentheses divide by XYZ. And then in that case, like we could have a coordinate system that points directly where the x-axis is that unit vector pointing at P or something. So yeah, I would encourage, like, if you've seen, I would encourage you to use this kind of vector description so that as you start introducing other coordinate systems, it's easier to keep track of where things are pointing. Like what, like that x magnitude, what x is it? Is it along this x-axis? Or is there another x-axis that's pointing somewhere else? And then what was XYZ? What did we figure out for that one? Yeah.
I did a question about like defining which direction is positive for y. Like,
okay. Yeah.
intuitively, the way it's set up, it looks like it should be negative, but EY is pointing in that direction, so I wasn't sure if it's positive or negative.
Yeah. All right. So this is a great like clarifying question. When we have a coordinate system kind of written up like this, that's defining positive, negative components for our coordinate system. So if I'm moving this way along that y-axis, like along that EY, then that's a positive, in this case, it's positive 3.64 along that EY. Because that's what's written here. Like instead of IJK, it's like EY, EX, EZ. And then same thing, like that Z is in that positive EZ component direction. So we had like 1.92, is that right? Kind of going up along that Z direction. And then I wrote this, like P/O. What is that, P/O? Why am I writing that?
2P from O.
2P from O? Something like that? Yeah, 2P from O. Is that, so some people, when I write that up, they're like, no, that should be from P to O. Have you seen that notation? Okay, good. All right, then we can stick to, because people have like sworn that yes, in statics, if you have PO, that means you start at P, go to O. I'm like, no. It's always the destination with respect to origin. So you're saying like, how did I get to P with respect to starting at 0? That's what we're saying. So position, because that R is position here. Position of P with respect to O. Because we could do the opposite. Like we could go from P to O, like O/P. And if we already know P to O, we can just multiply by -1 and travel backwards. What was the X component? How far did we have to go? 6.98, like around 7. All right, cool. Nice. We're moving. Getting started. Yeah. Oh, you got 0.92?
Oh, no, I did the same thing. It's 'cause, like, the one is
okay. Oh.
Oh, it looks like, yeah. Yeah, this is 1.9 and 2. Yeah. But otherwise it would, if there was a 0.92, then yeah, it would be whatever height that box is. Cool. Oh, yeah. Why put the in this, so I used EX, EY, and EZ because they're already written on my coordinate system of like, these are the directions of EX, EY, and EZ. EX is parallel to that 4.71 length. But I could, like just how I put there, like there's an I pointing that way. I could have a J pointing up this way, and then a K pointing that way, and then replace them all because they're equal. What's the difference between a vector and a unit vector? What's a vector versus a unit vector? Yeah.
A unit vector is in the same direction.
Yeah, so unit vector is always magnitude of 1. So a unit vector, the main thing is that, so vectors in general are magnitude and direction. Unit vectors are just direction. So it's just saying something about like, it's 10 degrees off of this angle, or it's parallel to this axis. Unit vectors, super helpful, especially as things start getting more confusing. Oh, 1.2. I want. All right, some more kinematic questions. We want RPO, RPQ, and RQP. So what are those, if we're just drawing arrows to represent those vectors, what does that look like in this diagram?
Draw a line.
So RP here is from 0 to P. What's the position? So if I have PQ from Q to P.
Nice color coded. Yeah, exactly.
So Q to P. So our PQ is for Q to P.
You don't use a slash. No. Yeah. That's the one that I've seen. If there's no slash. I think for the most part, every physics textbook like something like position versus slash. Oh, first time. Yeah. Really? It's supposed to be like I think it's in that here in Johnston.
I mean, we just put the same vector by arrow.
I'm literally not hard to tell through the core drawing skills, but RPQ and RQP go in the opposite direction.
Yeah, that's what I don't like about it. It's only one color.
That one is, it's just saying like,
That's right.
like
That's right.
it's using like a cursive eye. Sometimes it's labeled I.
Imagine just turning in your
But if it's like a good word,
Why did you only use blue for the first half? Oh, I hate the blue ones.
because like, you know when Rizzy takes notes, he'll like use different colors to figure out, so he shows different shades. If you just pull them like that.
Wait, so
Or like a crayon drawing.
goes from
If you have like words in paper. It feels like an actual piece of wood on the back.
That's sometimes I think now.
Okay, cool. So far I saw everybody. Usually PO, we just talked about this one, so nailed it, done. And then PQ, red or green. I just wanted to exclude all the colorblind men in the audience. Sorry, I didn't mean to use red and green. At least not directly, but red, brown, yeah, gray, the lighter gray. Yeah, sorry. it's like the one inclusive thing that men are like super on board with. It's like, yeah, we need colorblind access for everything. It's like, can't we be inclusive for every, like, if you want colorblind access, can we do like equal access across the board? Yeah, I always kind of laugh because like the first thing a lot of men talk about when they're like, yeah, we're very inclusive. We have colorblind accessible like lots and stuff. It's like, there are other types of disabilities that might need access to this material as well, right? Okay, that was so. Oh, yeah.
Like, if you're genuinely blind, how are you supposed to take lecture notes?
That one, I mean, yeah. So you can. It helps a little bit, like with YouTube, it does create a transcript. So that one helps a little bit, but it's AI generated transcript, so whatever. And then it's hard. And then we had the last one. If we're going Q with respect to P, then we have this one. Do we know anything about relations between these vectors? Like RPQ and RQP. What are those? Yeah.
Negative one of negative the other.
Yeah, RQP is negative RPQ. Oh my god, can't write today. What else? Do we know anything else about this? Just give it.
Sorry, I'm slow. Can you just re-say when you have P over Q and like Q over P, like which one you start and which one you go?
Yeah. All right. So this is what I always, when I'm reading this in my head, like physicists, mathematicians, they love to like shorten everything to the point where it's unreadable. So when you write R of P slash Q, you're saying position R of point P with respect to Q. So in my head, every time I see P slash Q or whatever, A slash B, I'm reading out in my head position of A with respect to B. So that's kind of the, yeah.
So the R dash just like saying to that.
All right, let's do some quick, like, this is, so this is not a hard and fast definition, but this is kind of like general, agreed upon for this class. We'll use this kind of notation a lot. All right, so.
Is it R bar or arrow?
I use R bar. I have seen arrows. It's easier for me to write LaTeX for bars rather than arrows on top.
I just learned that there's R bars and other classes for like other things. So just want to make sure.
Oh yeah, sometimes bar is like average, right?
Yeah, there's a couple different things.
Yeah, but in this textbook, bars mean, well, bold or a bar is vector. So bold things are vectors and bars are vectors. So dynamics, general notation. R. So if it's R like this, it's a position vector. V, what do you think that one would be? Volume. No, yeah, velocity. Yeah, velocity. Let's give myself a little more room. R dot equals V. What am I saying there? Yeah.
The derivative of r with respect to time is a velocity.
Yeah, so shorthand notation for like derivative with respect to time is that little dot. So r dot is saying d dt of r equals v. So the time derivative of position is v. And these are just kind of like general things that we'll use a lot. Another one, well, like an acceleration vector. So how would v and a, so v bar and a bar, what's the relation between those two? Yeah, the derivative. Yeah, so we can say a equals v dot. Cool. Or this is r double dot. And then there's like other things that we can talk, like we could also say that like v is some magnitude v, where it's like the speed is the magnitude of v, and then that et is some like tangent to the path kind of thing. But that one, we'll get there. So anyway, that was a long answer to the question of like, why are we writing, is r just like a vector? R in general is talking about like, what is the position of something? So we might also want to talk about like, what is the velocity? So if these 2 points are next to each other, what's the relative velocity of one to the other? And so if rpq is negative rqp, I can take derivatives of those and say that the relative velocity of p to q is negative velocity q to p. Yeah. Yeah.
So when we made r into a unit vector, when we're writing the notation vector problem, instead of using like r, we use like e with like a unit vector. Like,
Yeah.
why do you change it to e?
Why e instead of?
Write it as a unit vector.
Let's go back then. You mean like in that EPO?
Yeah.
So I wrote it like that. Another thing you could
Like, would you always do that if you write r as a unit vector?
So really what I was trying to say is like, there is a magnitude r, which is that x squared plus y squared plus z squared. So r times the direction of that vector still gives me the same vector, rpo. Yeah. So that's what I was trying to get at. But the notation that you use for the unit vector, whether it's like I or like an I with a prime or something, like some kind of like dash to say this is a different unit vector, as long as you keep track of what unit vector is what, it's always tracking some direction, and that's what we're trying to do with those unit vectors. Again, that's why it helps to like explicitly write out like what is this unit vector and where is it pointing, so that we have a little bit of bookkeeping along the way. Yeah, that was a good question. Nice. This is why it's nice to do this together, so that when you're home, it's like, all right, maybe I got it right. I don't know. Who knows? And it gives me some insight into like what it's like trying to deal with this stuff. Because I've been doing this now. When did I go to undergrad? Oh wait, 22 years now. So this is becoming kind of like standard practice for me. It's hard to like rewind back to the time when I first saw this. The first time I took dynamics, I got an A in the class, but I had no idea what I learned. I left and I was like, there was a determinant at some point and like I wrote it, I got an answer, like somehow I got credit for it. I was so lost. So my main goal has been like, can we make it more actually understandable, this class? Because it's awesome, super important, very interesting, but you can get bogged down in a lot of these like details, like math details. Oh yeah, last thing that I was wondering, do I know anything about RQO? What is RQO? We're not asked for this, but I was just.
It goes from O to Q.
Goes O to Q. Yep.
Be the sum of
Ooh.
R, and R2.
Summing something. So we get some sums in there. So yeah, it is. Now we'll use orange. So I can do like tip to tail addition, right? That it is R of Q slash P plus R of P slash O.
I might be onto nothing here, but like when you add them, the P's cancel, and you get like Q over O.
Then you get Q over O. Yeah, which is and really that's all. We didn't make anything like magic. Like we didn't discover new information. But there's a lot of times where like we know how to get to P. We know how to get from P to Q, but we don't know how to get to Q directly. And so having this helps out. It also helps for like if I know velocity of P. So if I'm on a train moving, I know my own velocity, and then I watch something fly by, I know its relative velocity. If I want to know total velocity, then it's going to be mine plus whatever I saw. So it's also telling us same kind of thing. But yeah, it does cancel out, and you end up with. And then acceleration, we can use the same principle. All this extra stuff. And we're on to chapter 2. Chapter 2 is a little longer. So in the readings that I suggest, there's like just a couple of. All right, so free body diagram of this barbell. Creatine. All right. We need free body diagram of barbell. So as tempting it is to draw a representation of that shirtless muscle guy, we're just considering the barbell, the thing that he's holding. That's just the eye candy for the problem. So we need free body diagram of barbell.
Can we draw like a point, or do we have to draw the barbell?
That's up to you. Can I draw it?
No.
Yeah, this is the third. Free body diagram of the barbell.
Well, so it's easier to like screenshot from here and like upload it to my document, which will take like a second. And then write on it. Yep.
Double this together. Or just sum it together.
No, yeah, actually. I'm just looking for it.
Yeah.
And you have to account for the bar itself as
Yeah, we'll look at it.
So is the barbell affected by
I'm pretty sure it's just weight and then normal force of each hand.
Like it's like just the mass of the body or wherever, and then the mass.
He's curved.
it's accelerating.
Yeah.
But if it's not accelerating,
So you're not talking about air resistance in this out, okay? This is air resistance free out. This is frictionless zone, okay?
oh, have you seen those memes where it's like when the professor assumes it's frictionless and the guy was on like a soccer stadium and he's gliding around that thing?
I have plenty more.
well, this one was just asking about that's another question. It's like a different.
You just read it. But this isn't an argument. I know, that's what I'm saying. If I wanted to be an argument course, yeah, well, it has to be. No, one of my questions was,
You might have more success like after the stuff instead of like going to high school. Nowadays.
they tell you how to do it.
Well, it's relevant for you if you drop out.
1,000 light years away.
Now you oh, okay.
That's why they say everyone.
I'm gonna get I'll get I want to get I want to apply just to get the line. Just to give yourself an excuse to learn from
Dude, I remember that like before. It was in my physics class.
And then there's another one too, it's only one month.
You know, Logan did that for his math final exam. You know, Logan did Claremont.
Yeah.
He printed out his equation, but he printed it out with like an actual image of SAE in the bottom right. So you can do it. You go. Oh, you didn't even need the equation. I was like,
Oh no, is it the weekend already? It's 9:55. Is it time to go? All right, we got 2 minutes, right? All right, let's do. This was like first level that I saw of like there's weight and there's a force opposing weight, something like that. That was like the point mass assumption of just like get everything. Can I show the other two things that I saw? You can call it norm because whatever.
Everything's a normal. Do we want to have this conversation again?
okay, I guess we can write R1 and 1 doesn't matter.
So like if we add the person plus that, then it's saying like that whatever FL that the person is creating FL, which equals W. So there is person is creating W on the bar. The next one that I saw was kind of like weight 1, weight 2, kind of F1, F2, and then maybe even like W center, like a more involved kind of thing.
Can you do one weight force just in the center?
And you could you could say like all of them are combined into one, like sum them all up, as long as you know that there's no like torque being created from them. Or you could do something kind of in between the two. Saying there's an F1, F2, and then a weight in the middle. So on Monday, you don't have to do anything more with this, but think about why would you use 1, 2, or 3? What is that helping you do? What kind of question would that answer? All right, thank you. Have a great weekend. We're on to week number 3 on Monday. Already there, a fifth of the way in.
So, I need to talk to you real quick. You know